As the UK and Ireland push towards net zero by 2050, the floating offshore wind turbines will play a major role. But there's a catch. Building these massive structures still relies heavily on materials with a high carbon footprint. The concrete floaters are attractive option for floating wind turbines because they are durable, cost effective, and can be produced locally. However, the cement used in traditional concrete is responsible for a significant share of global carbon emissions. Hi, I'm Jittu. I'm a civil engineer and doctoral researcher at University of Strathclyde, part of NHI CDT. And my research focuses on one simple question: how do we build the infrastructure needed for clean energy without creating more carbon in the process? The challenge is finding concretes that are not only low emission but also strong and durable enough to survive decades in harsh marine environments. Working in collaboration with ESP, I'm exploring alternative options such as fly ash, blast furnace slag, and calcined clays, many of which are industrial byproducts that would otherwise go to waste. To create the low emission concrete, I'm also exploring performance enhancing additives that enhance the durability without increasing the environmental impact. At a high level, my work involves engaging with industry to understand materials availability across the UK and Ireland, the material characterization and structural modeling to assess how this concrete perform under offshore conditions. This research could significantly reduce the carbon footprint of offshore wind infrastructure and at the same time support local supply chains, lower material costs, and help ensure that renewable energy projects are truly low carbon from its start to finish. For me, net zero isn't just a policy goal, it's an engineering challenge. By rethinking the materials we build with, we can accelerate the transition to clean energy and create infrastructure that supports a low carbon future.